All right, and we'll finish off the radicals with an application. This is called Kepler's Law. It has to do with astronomy. I will tell you I'm not an astronomer, so the astronomers out there watching are probably going to cringe. But anyway, the idea behind Kepler's Law, Johannes Kepler, I believe his name was, a mathematician and an astronomer, but basically when our planets orbit the sun, for example, let's call that planet Earth. If you look at planet Earth from a satellite photo, I believe it looks like that with a little smiley face. But basically, Kepler's law, third law, says that the number of miles, the average number of miles between that planet and the sun is the m, and then the p is the period of that planet, the period. How many years does it take that particular planet to make one full orbit around the sun? So, for example, does anybody know how many years it takes our planet to make one full orbit around the sun? What's the period of planet Earth? Right, that's exactly right. It's 1 year. Mr. Sock Puppet is so proud of you guys. But anyway, that's right. Our period is 1 year. So there's a math relationship between the number of miles and the period of the planet. All right? So anyway, this particular question comes to us from, again, astronomy. So it mentions in the question Pluto, and it gives us the average number of miles that Pluto falls from the sun. Pluto is way, way, way farther out there than the Earth. All right, so let's put Pluto out here. And here, again, satellite photo. Pluto is a little bitty planet with a P on it. And it's way, way, way farther out there. Okay, in fact, it's this many miles. Well, that would be the m, wouldn't it? So let's take the number of miles between Pluto and the sun and put it in for m. By the way, I'm going to bore you with an old man story here because I'm getting kind of lonely. But this particular formula actually came into my life when I took my children to the Air and Space Museum in Washington, D.C. many years ago. And there was a display about Kepler. And so I'm looking at that display and I was thinking, I need to take a picture of that formula so when I get home from Washington, D.C., I can look it up and maybe make a math question out of it. So anyway, I'm lining up a picture of the formula here with my camera. This was before I had a camera phone, and a phone camera, whatever I'm trying to say. And I'm lining it up, and I feel a little a little tug on my pant leg, and it's my little daughter, and she's looking up at me, and I go, "What? Do you need to go to the bathroom again?" And she said, "No, Dad." She said, and she pointed to her brother, "We're not in the picture." And I said, I didn't really have the heart to tell her that I didn't really want her in the picture because the formula is more important than her, right? Good parenting here, isn't it? So I was like, "Oh, what's wrong with me?" So she and her brother go over there and they stand in front of the display, and it turned out that they were standing right in front of the formula. And, Daddy wanted the formula more than anything else. So I was like, hey guys, the lighting is a little bit better over this way. So move over a little bit. Okay, now crouch down a little bit. Okay, yeah, good. And I snap a picture and get the formula. So anyway, somewhere in the Sodergren archives at home, in a shoebox somewhere, is a print of a photo of a math formula and two little cut off blonde heads sticking in the bottom of the picture. And I've looked and looked for that, but I haven't been able to find it, so darn the luck. But I will tell you this, I was lucky enough one semester that actually Mr. Johannes Kepler came to class here. You can see that he's sitting there with his Kepler jersey on, looking at the very question that we're working on right now. So I'm so glad that Johannes Kepler came to class. That's for you, Aaron Main. Appreciate it, Aaron, for wearing your Johannes Kepler jersey to class last year. Anyway, back to solving the equation. Like I said, I'm lonely. I miss you guys, and I miss telling you all those wonderful stories that keep you so entranced. But this would certainly be a radical equation. There's the radical, and we want to isolate it. So, wouldn't we want to get rid of this number? And this number is multiplying with the radical, so wouldn't we get rid of it with division? So this would be all that process of isolating something by introducing its opposite, its inverse. So those cancel, and we're left with the radical then. Cube root of p squared. And then over here, we just divide those numbers. So again, 3, 6, 7, 5, 9, 0, 0, 0, 0, 0, divided by 9, 3, 0, 0, 0, 0, 0, 0, equals 39 point blah, blah, blah. Now, just keep all those digits in your calculator. And there we go. All right, now what? Well, like we've seen before, now we've got the radical by itself. Now we want to get rid of it. We've done this on a few examples previously. I highly recommend changing that into a fractional exponent where it would be 2 over 3. 2 over 3. That's one of those radical definitions from assignment 7. All right, and that's why we went over that in preparation for this. All right. You know, I mean, I'm looking at my list of names here that people have called me. I'm trying to look for a new one. I don't know. Mr. Sodium chloride. Maybe I used that one already. I don't know. But Mr. Sodium chloride has a plan. But if that's 2 over 3, wouldn't you want to introduce the 3 over 2 power to both sides? And again, the properties of exponents tell us that when you apply one power on top of another, you multiply them. And so 3 over 2 times 2 over 3 is 1. So that effectively leaves us with p to the 1th power. And then this side, when you parentheses raised to the parentheses, this is 248. I'll round it to 5. It's like 49, whatever. All right, and keep in mind that the p here, the p value here, is what they call the period of the planet. And it's how many years it takes that particular planet to make one full orbit around the sun. So Pluto is going to take almost 250 years to make one orbit around the sun. Why? It's farther out, way farther out. It's going to take longer than it does the 1 year for planet Earth. I wanted to share with you, you can quit watching if you want, that's done. Unlike class where you're stuck here and you have to listen to Mr. Salivary Gland ramble on with his stupid stories. But, so anyway, I just wanted to share with you that you guys maybe have seen this company called the P1 Group, all right? And so I would always see their vans with the P1 there, and you know, and that's awesome. I don't know the people, I bet they're awesome people, but I've always thought, well, P1, P to the first is just P, isn't it? So why would you need that first power there? Couldn't you just call your company the P Group? So anyway, I used to drive past a house that had a P1 Group van parked out, and one day I finally got the courage to pull into the neighbor's driveway to get a picture of it. I'm sitting here in the driveway, and I'm sitting there getting ready to take that picture, and the neighbor comes walking out. I understand why, and he kind of looks at me, and real quick, I thought, what am I going to do? So I put my phone up to my ear like I had pulled over to make a call, and I just kind of turned again, and I said, I'm sorry, I pulled in your driveway to make a call. And he's like, oh, okay, and he walked off, and then I got the camera and snapped the picture you see up here, or maybe you can't see, I don't know. But anyway, enough of that. I think we're done with radical equations. So I guess I will now leave you with a little bit of my favorite artist of all time, my favorite math musician. So here's Algebra covering old-time rock and roll with old-time radical.
Just take those old math books off the shelf. I sit and solve equations by myself. The other subjects ain't got the same soul. I like that old-time radical. Don't try to take me to an art class.
What can I say? I don't know.
I'd rather integrate and calculate math.
Other than math, I need to get a hobby, right?
Ain't got the same pull. I like that old-timer radical. Still like that old-timer radical. Fractional powers just soothe my soul.
Fractional powers, you hear that?